very good day to Doctor. My name is Daniel Ganifan, AE1900077. Today I'm going to do a presentation on exercise 6, BV20501, Electrical and Electronic Lab. So I'm going to explain about what is the theory and the introduction of electrodynamometer, voltmeter. So, okay, here's a figure of an electrodynamometer type of a voltmeter. So there's using two coil. One is a moving coil and one is a fixed coil. Okay, so that the operation principle is a very simple and straightforward concept. That the operation is based on the assumption that a current carrying conductor in the magnetic field experiences a mechanical force. So the mechanical will force the carrier scale pointer to deflect. So as you can see here that they have a scale of moving over here for the moving coil, and this is load, this is resistor, this is supply voltage. So there are two coils, moving and a fixed coil. So the moving coil will move the pointer as well, and to minimize the heating current flow for moving coil, that's unlimited, restrict current for the high flow, and then we're using a resistor over here, so series resistor. So for the fixed coil, that is divided into two equal portions, which is a series with the load, and the load current pass through this coil. So over here, I have using this the fixed coil is connect series to the load. Okay, and the power factor is a measurement of how efficiency that use of electricity. So it's a real power divided by a reactive power. So you can get 1.0. That's the best power factor, which is a unity power factor. Okay, thank you.
Hello, Assalamualaikum. So my name is Elisa Apira. My card metric number is AE1900067. So I will show you the procedure on how to create the circuit for activity 1 and activity 2. So first we need to delete this first. So first we need to set the battery as the DC source for the circuit. Then connect it to DC voltmeter, where DC voltmeter is to find the DC voltage for this circuit, and also the DC ammeter to check the current in this circuit, and also the wattmeter to scale the power in this circuit. And last component is resistor. So we just connect it all. So for battery, we set to 60 volt, and resistor is 100 ohm, and for wattmeter in watt. So I will run. So as we can see, the voltage is 60 because it's parallel, and the current is 0.6 amp, and the power at this circuit is 36 watt. And for activity 2, so we just need to change the circuit to AC. So we delete this one, and this one. So alternator as the AC source. Okay. Oh no, sorry. AC voltmeter, AC ammeter. So for the amplitude is 100 volt because at the manual they said the V peak is 100 and frequency is 50 Hz. And all the others is still the same as activity 1, so I will run it. So yeah, for resistor on 100 ohm, the AC volt is 70.7, current in AC is 0.71, and for power is 50 watts. So that's all from me. Thank you.
Okay, very good morning to all the lecturers who is watching this video presentation today. My name is Lee Jin Zhou, and I'm going to present with you about the activities 3 in the exercise 6. And here is a circuit I have designed by using the Practice 8 Professional. Here is the alternator, also got the power supply. Here we got the AC voltmeter, power meter, RL resistor, inductor, and also capacitors. So if we make this simulation running, and both of these meter will have a record after the value has been constantly, and we can take it down and record it into the table. And next, the display range we need to change to VA also, and we can run again and read the VA in this circuit with the same method. We stop the simulation and we can change the value of this to 2, 4, 6, 8, 10. That's all. After that, we look back to the reports. So here is the calculation part for 2 microfarad. The XC should be 15,000 and 91.55 ohm, and for 4, 6 is the value respectively 8 also and also 10 microfarad. And after that, we are going to calculate the value for the angle and also the Z. So for 100 ohm plus 2 microfarad, Z is equal to 15,000, 94.69 ohm, and the angle is 86.40 degree. And for 4 microfarad is this 2, for 6 is this 8 and 10 respectively. And this is the table recording all the value that we have read from the simulation. This 2 and calculated, this one calculated, and here is the power factor also calculated. After that, we are going to put it in here. Power factor for 100 ohm plus 2 microfarad is 0.064, and for 4 is 0.125, for 6 is 0.186, 8 is 0.243, 0.299 for 10 microfarad. So the exact value of resistance RL has been used for each of the 5 loops, as shown as the table 6.3, and the capacitor value. However, difference for each of 5 loops being 2 farad, 6 farad. Sorry, should be typo. Should be micro. As a result, and all this you can go through in the reports.
Very good day to Doctor. My name is Daniel Ganifan, A190077. Today I'm going to do a presentation on Activity 4, PV20501. So, over here I'm using this 3 formula to calculate my reactance, the overall resistance and angle of the power factor and apparent power, real power. Okay, so I'm going to simulation of Power Lab on a Proteus 8 using this. So I'm going to construct a circuit based on this. Then I'm going to calculate this or the formula. I'm going to insert it into the table over here. You can see. Okay. So I'm using this 100 ohm and 0.02, which is 2 milliampere, 2 millihenry inductor. So as you can see over here, 100. This is voltmeter connection. AC emitter reading with a milliampere and AC volts. So this is a switch. Open it. So I'm going to run my circuit. I'm using 100 volts of AC and 50 hertz of frequency. Okay, so you can see nothing happens. I'm going to turn on the switch. So it's going to happen over here. The AC voltage is around 70.6 and ampere is 0.706 and the volts will be power 49.8. Okay, so as you can see over here is equal to the same because the apparent power and the real power, it's almost identical when you are using this power measurements over here. So I'm going to change my inductor to 10 millihenry. So let's see. Okay, as you can see, nothing much happens for the power over here, and it's also the same over here. So it's almost the same. So I have to get a power factor of a unity 1.0. Thank you.
And next is the conclusion part. So as a result of this exercise, we learned the principles of direct current and alternating current power measurement for single phase loads, as well as more about the electrodynamometer, wattmeter, and in its applications. Aside from that, there are numerous activities for us to perform in this exercise, such as measuring electrical power in DC circuit and measuring electrical power in an AC circuit with various loads such as resistive, capacitive, and inductive loads. Furthermore, we are able to acquire, discriminate, and compute values from our hand formulas, computations, and simulate the values of them from simulation of similar operation utilizing software application on our computer. So finally, we're able to go through, comprehend the outcome and data that we had acquired, as well as provide explanations for the observation and conclusion that we have made during this exercise. So that's all from my presentation. Thank you very much. Thank you for your attention.